Good afternoon. Welcome to today's webinar, Hazards of Walking Surfaces. During this webinar, our presenter will cover the following topics: hazards found on common walking surfaces, characteristics of sidewalks, paved areas shared by pedestrians and vehicles, stairways, ramps, elevated landings, catwalks, and other common walking surfaces. Walking surfaces accessible to the public. Restricted walking surfaces such as those found in industrial areas. Walking surface standards associated with the Americans with Disabilities Act. Standards and codes affecting the configuration, slope, maintenance, condition, material, and railing requirements of walking surfaces. Characteristics that control both tripping hazards and slipping hazards in walking surfaces. Today's webinar will feature Bob Illo. Bob is the principal architect and engineer for Architecture and Engineering Innovations, located in Mountville near Lancaster, Pennsylvania. Mr. Illo holds an architectural license in Pennsylvania, New York, New Jersey, Delaware, Maryland, Virginia, West Virginia, Massachusetts, Indiana, Ohio, Mississippi, Louisiana, New Hampshire, and Texas. He holds licensure as a civil and structural engineer in Pennsylvania, Maryland, Delaware, New Jersey, Indiana, Massachusetts, Ohio, and Mississippi. Bob has over 25 years of experience in architecture, engineering, and forensic evaluation and restoration services for residential, commercial, industrial, and public property design. He's been called as an expert advisor and witness in numerous property safety and construction litigation cases serving plaintiffs' counsels, defense counsel, and insurance companies. He continues to provide accurate forensic evaluation and remediation measures in matters involving the built environment. Bob is a member of the National Trust for Historic Preservation, National Society of Professional Engineers, National Council of Architectural Registration Boards, as well as the American Institute of Architects. He holds a Master of Engineering and a Bachelor of Architectural Engineering from Pennsylvania State University and a Bachelor of Architecture from Drexel University. If you have a question that pertains to the presentation, I ask that you use the chat or Q&A feature found on the right-hand side of the screen to submit your questions. Bob will do his best to answer your questions during the presentation. Tomorrow morning, I will send out an email with a link to the archived recording of this webinar, as well as the PowerPoint presentation used during the program. And we do ask that you take time to fill out the survey that will appear on your screen after the webinar is over. I now invite you to sit back, relax, and enjoy. I'm now going to turn it over to our distinguished presenter, Bob Illo. Bob, it is all yours.
Hey, Matt, thanks very much. I appreciate that introduction, and thank you all for attending. Good afternoon to each of you, and welcome to our discussion about walking surfaces this afternoon. My name is Bob Illo, and I'm an architect and engineer with experience in the design of walking surfaces, among other components of the built environment. I'd like to ask you just to take a moment before we get started, or as I'm getting started, if you would, to type in either into the chat space or the Q&A space. Chat space is probably best. Your name and the kind of work that you do to help me get to know you a little bit better. Also, during the seminar, please feel free to type in any questions that occur to you, and I will address them as I'm able and as they're appropriate in the flow of the seminar. So, getting started, today we're going to be talking about walking surfaces. Walking surfaces have occurred in nature for as long as there has been a place to walk, and probably before man invented litigation. Unfortunately, Earth's wrinkly old crust is difficult for bipeds to negotiate. So, to compensate for our two-legged disadvantage, mankind invented walking surfaces to accommodate pedestrians. Unfortunately, not all of man's inventions are pleasant to interact with. If walking surfaces are not properly designed, constructed, and maintained, they can be a hazard rather than an accommodation to pedestrians. So today, I'd like to examine commonly accepted standards of design, construction, and maintenance for walking surfaces. During this seminar, I will focus on physical components of walking surfaces, and I will describe the intent of recognized codes and standards that regulate conditions found in walking surfaces. I will not name or cite chapter and verse of specific publications, since we can cover more territory by making general reference to the intent of the codes and standards, and the focus of this seminar is to cover as much as we can on the physical conditions of the walking surfaces. So I will start with the idea of a planar walking surface. That does not mean level necessarily, but in the same plane.
Excuse me, Bob, I think you're breaking up a little bit.
Yeah, I hope that everybody can hear the audio.
Yeah, you were just breaking up a little bit there. I didn't mean to interrupt, but you were breaking up a little.
Yeah, is there some spot to which I should go back to make sure everything has come through?
No, I think everyone's here, but you're still breaking up a little bit.
Yeah, I'm just checking the connections on the phone. I'm broadcasting into the phone. So the idea of planar deals with changes in elevations. And an elevation change within a walking route, of course, is unavoidable because the earth is not flat, despite the beliefs of some groups, but it does have ups and downs. Newly designed walking surfaces must take these elevation changes into account. So standards exist to limit the height and the profile of these elevation changes. The height is dependent on the type and location of the surface. The profile can be rounded or it can be beveled, depending on the height, the material, and the location of the change in elevation. So when changes in elevation within a walking surface occur, they're designed so that they can be made noticeable. They can be designed to be made noticeable by changing the color and by changing the material at the edge of the step. Similarly, random patterns can camouflage a step and should have a clearly delineated edge at the elevation change. Sometimes a change in elevation occurs in a walking surface that was not designed into the walking surface, but is the result of poor construction practice. Where different materials adjoin each other, poor alignment during construction can cause a tripping hazard. A designer can take this into consideration by using changes in material in a careful way. Likewise, changes in elevation can develop from improper maintenance practices. Water can migrate through poorly sealed joints below the paving material and cause subgrade to deteriorate, to subside, or to heave upward from frost, resulting in a tripping hazard.
Excuse me, Bob, I think you're breaking up again with the audio. You were good for a little while there. I'm getting some messages, and I'm hearing it on my end, too, that you're breaking up a bit.
Yeah, I'm hearing it both ways when you speak as well, and I'm not sure what to attribute that to.
Do you have your computer speakers on?
I don't.
Okay, so you're not getting reverb. I don't know. This seems like you're breaking up a lot.
Yeah, I'm seeing that in the comments that my audio is breaking up. I don't know why.
Okay.
So what I'll do is continue. Hopefully we can salvage that. I'm going to turn off anything electrical near the phone. Sometimes that can cause some noise on the lines.
Yeah.
So we'll continue, and I'll speak slowly so less is missed. So we're continuing to talk about changes in elevation, and ramps can be used for a change in elevation that covers a large height differential. Most codes and standards define a ramp as a walking surface with a slope greater than 1 vertical unit for every 20 horizontal units. When the walking surface slope exceeds the rate of 1 in 20, the surface is called a ramp, and special requirements apply. Ramps must be constructed to a minimum width, depending on conditions, location, and use of the ramp. Most ramps must be 5 feet or wider. Ramps are limited to a maximum rate of slope. In most cases, this rate is 1 vertical unit for every 12 horizontal units, or 1 inch of rise per foot of run. So a ramp that connects a sidewalk with a landing that is 20 inches higher than the sidewalk would have to be 20 feet long. Ramps cannot exceed 30 inches of rise. For ramps that connect walking surfaces with a change in elevation greater than 30 inches, a landing must be provided. Landings must be at least as long as the width of the ramp. Any ramp with a total rise of 6 inches or more, depending on the applicable code, must conform to requirements for the configuration of its edges. These higher ramps must have curbs or alternate structures at the edges to prevent the wheel of a wheelchair or a foot from traveling over the edge of the ramp. Railings are also required at the edges of these higher ramps. Ramps with less than 6 inches of rise are exempt from these edge conditions to allow curb cuts in sidewalks, for instance, so that those curb cuts would be free from railings that would obstruct pedestrian traffic on busy streets or in parking lots. Other regulations apply to curb cuts to prevent the edges, which are subject to cross traffic, from presenting a tripping hazard. Edges of curb cuts must be sloped or flared to eliminate a vertical edge. The rate of slope on these flares is allowed to exceed the rate of slope on the curb cut, but it cannot exceed a rate of 1 vertical unit for every 10 horizontal units, so that it doesn't become a tripping hazard itself. Another means of negotiating a large change in elevation is the use of steps. Like ramps, steps of a certain rise are required to have railings. The amount of the rise depends upon the location, usage, and governing regulation. But in most cases, any set of steps that exceeds 2 or 3 risers must have a railing. Building codes refer to the vertical portion of a step as a riser and the horizontal portion of the step as a tread. Now, the maximum and minimum heights of risers are regulated. Likewise, the depths of the treads are regulated. These limits are established to control the steepness of the steps. For most interior stairs used for egress from a building, the treads may not be less than 11 inches deep, and the risers may not be more than 7 inches high. Now, exceptions exist for these limits, depending on the usage of the building. All risers and treads within a stairway should be the same dimension. Now, most building codes limit the dimensional variation between adjacent treads and risers to 3/8 of an inch within the flight of steps. The surfaces of the treads and landings within a stairway should also be level. Building codes prescribe a maximum slope on these surfaces. On exterior steps, a slope is desirable to prevent the accumulation of water on the walking surface. The nosing of the tread must project past the riser. Building codes prescribe the amount of projection, usually about an inch. A projecting nosing allows more room on the tread below to support the foot of an ascending pedestrian. Stairs must maintain a minimum width as prescribed in the building code. Depending upon the usage of the stair and the volume of traffic the stairs required to accommodate. And most stairs are about 4 feet wide. Different widths will be required, though. Narrower stairs are permitted in some cases, and wider stairs are required in others. Stairways are required to have landings at intervals dictated by the applicable building code. Most codes limit the maximum rise of a flight of steps to 12 feet measured vertically. So, for instance, in a building that has 13 feet between stories, and that's not a common condition, by the way, an intermediate landing would be required in the stairs. Headroom is a feature of walkway safety, often overlooked in stairs and ramps. While descending a set of steps or ramps, the overhead structure appears lower, and it can present a distraction. So the code limits the minimum makes a minimum headway or overhead clearance requirement in stairs. Distractions of any sort in a stairway is discouraged, as with many walking surfaces that negotiate a change in elevation. As we discussed before, landings are provided in stairs and ramps to provide relief in the vertical progress of pedestrians, whether that vertical progress is upward or downward, or whether that progress is controlled or accidental. A landing can also be at the doorway or any other interruption along a walking path to provide a transition from the pedestrian's negotiation of the doorway to the task of stepping down or up a flight of steps or ramp. A landing can be a means of dealing with a distraction along the walking path, such as at a display or window or an advertisement. Landings are required at any change in the direction of travel along a ramp or along a stairway. Landings are often elevated above an adjacent ground or floor surface. Therefore, the edges of landings must be equipped with a railing, a wall, or another barrier to prevent a pedestrian from falling over the edge of the landing. Building codes place railings into two categories, guard railings and hand railings. The purpose of a guardrail is to prevent a fall over the edge of a set of steps, a landing, a ramp, or other elevated walking surface. A guard railing prevents a fall perpendicular to the direction of travel. The purpose of a hand railing is to prevent a fall down the ramp or steps. A handrail, therefore, prevents a fall parallel to the direction of travel. Guard railings are required at the sides of ramps, steps, landings, and any walking surface that is raised above an adjacent ground or floor surface. The amount of height above the adjacent ground surface that triggers a requirement for a hand railing varies and can be as little as 6 inches. Hand railings on stairs and ramps are required to extend beyond the tops and bottoms of the ramps or stairs. These extensions are provided to give the pedestrian cues and or assistance at the point of transition between horizontal travel and inclined travel. The distance and slope of these extensions are prescribed by code. The height of a handrail is prescribed by code to be at a height that is easily grasped by pedestrians that are using the stair or ramp, especially in the event of a fall down the stair or ramp. Most codes require handrails to be no less than 34 inches and no more than 38 inches above the plane of travel. Most codes prescribe that guardrails, by contrast, be at least 42 inches high. So as a result, stairs and ramps that require both a guard at their edge and a handrail at the side must have two structures, since the guard must be higher than the handrail and it cannot serve both functions of guarding and a handrail. Most codes require a handrail within 30 inches of any point along the width of a stair. Handrails must have a profile that can be easily grasped. This requirement does not apply to guardrails, since a guardrail does not rely on grasping to provide protection. Guardrails must be constructed with limitations on the size of the opening below the rail. Building codes prescribe a range of permissible opening sizes to ensure the effectiveness of the guard in preventing a person from passing through the guard, under the rail, and over the edge of a stair or elevated walking surface. The most restrictive opening limitation in a guardrail is 4 inches, usually for areas where small children or members of the public could use the walking surface, without close supervision or restraint. In other areas, such as inside an industrial facility, on an industrial catwalk or stairway, the permitted openings may be as much as 21 inches, where the catwalk or stairway or landing is used by trained authorized personnel only. Voids in a walking surface can present a tripping hazard or a stumbling hazard. Voids can be created by design where a grating is located in a walking surface, such as a steam grate or stormwater drainage. Now, most codes limit these openings to 1/2 inch or less. Improper construction can result in voids at joints in the pavement that are not filled with proper materials that allow for expansion of the pavement, but can support the forces imposed by foot traffic, such as spiked heels. Improper maintenance can result in voids in the walking surface as well, caused by deterioration of the pavement or uncontrolled movement at a pavement joint. A curb is a continuous change in elevation without a protective guardrail that can cause a tripping hazard. Curbs also provide the useful service of segregating vehicular traffic from pedestrian traffic, so their inherent hazard is tolerated because of the hazard that they mitigate. Despite their virtues, curbs should still be handled with caution. A curb must be made clearly visible and located in a predictable place. The top of the curb should be flush with the adjacent sidewalk so that pedestrians descending the curb do not trip on their way out into traffic. I see a question on the chat board I wanted just to take a look at for a moment. From Baxter Cooper. What standards are implicated where degraded or missing caulking in expansion joint in concrete floor allows high heel to slip into joint at a depth of 3 inches? Well, the standard would be a standard that limits the size of an opening in a walking surface, and most building codes do prescribe that for a walking surface, as well as the American Society for Testing Materials may have a standard on that as well. Second part of the question, what standards apply concerning the dimensions of expansion joints in concrete flooring? Well, dimensions for the width of a joint in concrete flooring often is dictated by the amount the concrete is expected to expand, and if that exceeds that 1/2 inch, then the previous standard would apply. So I hope, Baxter, that's helpful for you. The next subject is lighting. Adequate lighting is an important component in the safety of a walking surface, whether the surface is a level walkway, a ramp, or a stairway. Minimum lighting levels are prescribed for various walking surfaces depending on the usage and volume of activity in the area. These published light levels apply to the measurable lumens on the walking surface. Lighting designers must exercise judgment regarding glare from competing light sources when providing appropriate illumination levels on the walking surface. Also, the position of the light fixture plays an important role in its effectiveness. Shadows, veiling, and light level variations must also be considered in lighting design. The next part of our talk concerns slipping hazards, as we turn our attention away from tripping hazards. And I'd like to just invite anyone who has a question at this time to type that in, and I will do my best to address it.
Okay, thank you, Bob. And first, I'd like to apologize. We are still working on the audio issue. I know a good portion of the beginning was scrambled, and I apologize about that. We're still trying to figure out what happened, so please bear with us. I know there have been some requests to repeat some sections. I'd like to try to get through the bulk of this presentation if we can. If we have some extra time at the end, we'll go back and repeat some of the introductory sections that were lost when the audio was scrambled. So I do thank you for staying on the line with us and attentive while we try to fix the problem. Bob, we do have a question here that asks, it asks you to repeat the hand railing requirement. This person is working on a case where an individual fell down a landing with one step. Would a handrail be required in that instance?
Normally, a handrail is not required at a single step. Almost all codes exclude a single step from a handrail requirement. That's the short answer to that, but it would be beneficial to get on site and examine the conditions. If there is a change in elevation or drop-off of the walking surface on one side of the step, then a railing may be necessary depending on the height of that drop-off. So a handrail most likely not required. A guardrail might be required.
Okay, we have another question here from Jack, who asks, this is pertaining to a situation in a grocery store. The ramp was built to account for a height differential in the grocery store, which was built where there had previously been a movie theater. The code is silent as to the application of the New York City Building Code to this type of retail store. The sidewalls to this ramp are now both covered with shelves holding food for sale. The ramp is of a degree of slope that would ordinarily require a handrail. Is there any exception for this type of establishment?
Yeah, several factors are to be considered. One is the overall rise of the ramp. Most codes exempt a ramp that rises 6 inches or less from requiring a handrail. The shelving is serving as a guardrail, but not as a handrail, obviously. So if the ramp is more than 1 in 20 in its slope, 1 vertical unit for 20 horizontal units, then it should have a grasping surface if it negotiates more than 6 inches of drop. So there's no specific exception in the code where there is retail display. There is a specific exception in movie theaters for a railing at the edge of steps or ramps where the railing would prevent people from getting in and out of the seats in an egress situation. So the designer, in this case, should strive to put a structure on the side of the ramp that would allow a hand railing to be mounted if the rise of the ramp is more than 6 inches.
Okay, great, Bob. We have another question here that asks, I see landings and stairs in buildings that do not have 12 feet floor to floor. Why is that?
Yes, the landing in a stair tower is typically used for 2 reasons. One, it cuts down on the height of each flight, even though the flight does not exceed or not approach even 12 feet vertical dimension. And secondly, it allows the stair tower to be more compact. We call this a switchback, where one flight goes down in one direction, there's a landing, and then the next flight goes down in the opposite direction. And it just allows the stair tower to be of a different formation. And it is also an accommodation to people using the stairs to have landings more often.
Okay, great, Bob. I don't see any more questions from the audience, so if you want to continue on with the presentation of content, please feel free to go forward.
Well, sounds good, yes, and I'll be happy to continue, and also happy to answer any questions as they occur to you during the ongoing presentation. So now I'd like to turn attention from a tripping hazard to a slipping hazard. In the next part of the seminar, we'll take a look at slipping hazards. Coefficients of friction figure into slipping hazards, and the coefficient of friction is a commonly recognized measure of the slip resistance of a surface. Simply stated, a coefficient of friction is just the ratio of the lateral force required to cause an object to slip on a surface to the weight of the object. So if a 150-pound person must exert a 75-pound horizontal force to slide on a level surface, then the coefficient of friction between the soles of that person's shoes, assuming they're wearing shoes, and the surface is 75 pounds over 50 pounds, or 0.5. So the ratio is 0.5. The coefficient of friction is 0.5. As this example shows, the coefficient of friction is a function of two materials. Number one, the walking surface, and number two, the soles of the pedestrian's shoes or feet if they're barefoot. Now, designers and property owners only have control over one of those materials, and they don't have control over the pedestrian's shoes, so it's the walking surface. Walking surfaces should be slip resistant to avoid slips that lead to falls, and because a designer has control over only the walking surface and not the shoe surface, it is not common to see prescriptive requirements in the codes for coefficient of friction of a surface, since there's no such thing technically as a coefficient of friction for a single surface. It takes two surfaces to measure a coefficient of friction. So several characteristics of walking surfaces can affect slip resistance, however, and those I'd like to look at next. The first characteristic that affects slip resistance is the material of the walking surface, obviously. Material selected for the walking surface is important. The surface material can have tooth or texture that can both channel water from the surface to provide contact between the high points in the surface and the soles of the pedestrian's feet, or it can provide mechanical interlock with the soles of the pedestrian's feet or shoes. Several surfaces are available. Many materials can be used on walking surfaces, and they have varying degrees of slip resistance. Now, some of them include an unsealed broom finish concrete, as we saw in the previous slide. That's as opposed to troweled concrete. Concrete that is troweled can be made to a very smooth finish, especially if a sealer is placed on it. Quarry tile can be used as well. So can glazed tile of varying textures. The grout joints of the glazed tile or quarry tile can enhance the slip resistance in the surface of the tile. The glaze can be textured as well. So can the profile of the tile be textured to provide slip resistance. Bricks can be used as well. Some types of brick are more slip resistant than others. Misaligned brick can create a tripping hazard. Wood plank can be used as well. Joints can help aid slip resistance at the risk of creating tripping hazards. So wood planks, like bricks, if used in a walking surface, should be aligned in a uniform profile. Asphalt can be used as a walking surface. Carpet can be used. Textured epoxy also has a wide range of textures, and it can be used as a walking surface. Vinyl flooring, too, has a wide range of textures. Polished stone, while attractive, is often asking for trouble, depending on how it is dressed and how it is maintained. Terrazzo flooring is flooring made of marble chips set in a mastic, usually polymer mastic or cementitious mastic, and ground to a smooth surface. It can accomplish many different effects and patterns, and like polished stone, it should be used with caution. The selection of a material is influenced by many considerations besides slip resistance, such as aesthetics, durability, resilience, sanitation, and others. Often these considerations distract a designer from the slip resistance of the selected material. The slip resistance of some materials can be enhanced by cutting or forming grooves or texture into the walking surface. Grooves can channel water and can provide mechanical interlock. Grooves are not for all walking surfaces, however. It's not easy to make grooves in a walking surface look like they were done on purpose. For a finished formal appearance, grooves are not usually acceptable. On the other hand, grooves can be useful in concrete surfaces or in exterior or industrial areas. Similarly, abrasive strips can be added to a surface, as seen on these stairs, that is sufficiently slip-resistant. Usually, grooves, abrasive strips, or other remedies on a walking surface are evidence that somebody failed to consider slip resistance in the selection of the material. Some surfaces can be coated. Many coatings are available, which can be applied to walking surfaces, and the coatings can provide and alter the appearance of the surface, even provide information, such as marking a parking space or striping in a parking lot, and it can also affect the texture of a walking surface. Some commonly used coatings might include traffic paint, also epoxy floor paint. Trowel-on polymer flooring is a type of coating, although thicker and with more textural variance. Swimming pool paint is another commonly used coating on a walking surface. These coatings have an effect on the slip resistance of a walking surface. For example, this statement is found on the product data sheet of a widely available traffic marking paint, warning against its use on a walking surface. The slip resistance of a coated surface can be enhanced, however, by adding sand to the coating or other type of grit or method of application that would change the profile or give tooth to the coating. The slip resistance of interior coatings can be enhanced by controlling the profile in this way. As a coating wears, its slip resistance can often be reduced. The term contaminant, as it relates to walking surfaces, refers to anything on a walking surface that can get between the walking surface and the sole of the pedestrian's shoe, making it slippery or maybe less slippery. Common contaminants include water, oil, soap can be found during cleaning operations. Fruit is a common contaminant, not just in an apple production facility as you see here, but say in a grocery store, such as a fresh grape or the iconic banana peel. Fine powders, such as wheat flour, can act as a contaminant on a walking surface. Syrup, juice, or other beverages can act as a contaminant. Clearly, some contaminants cause a greater slipping hazard, and other contaminants may actually prevent slipping or cause tripping, such as a heavy syrup. The designer of a walking surface should anticipate the probability of contaminants. For instance, the floor in the produce area of a grocery store should be lit brightly and free from patterns that could camouflage produce. The color of the flooring should be light also to allow any spills to show up. In addition, multi-directional direct lighting on the floor can be specified to reflect any produce or liquid that is similar to the color of the floor. In industrial areas, grit can be incorporated to create a large amplitude in the floor surface to provide mechanical interlock to overcome the effects of contaminants. Ice is another slip-causing sort of a contaminant. It's difficult to control. On exterior walking surfaces especially, ice can accumulate and can cause severe slipping hazard. Ice can form on walking surfaces from several sources. Direct precipitation is one most common source. Another is overland stormwater runoff. that freezes. Runoff from roofs. Again, liquid at some time of the day, and then at night when the temperatures drop, roof runoff can freeze. Also, melting snow from a plowed snow stockpile located uphill from a walking surface can create an ice flow. Several measures can be taken by designers, contractors, and maintenance personnel to prevent ice accumulation. One method is to provide a canopy to keep precipitation off of the walking surfaces. Another would be to provide proper grading to direct runoff away from walking surfaces, have the walking surfaces on the high ground. Also, a selection of a stockpile location for plowed snow that prevents runoff of snow melt from running across the walking surface, but instead will be channeled into underground drainage structures. Proper downspouting from roofs can direct runoff away from walking surfaces rather than onto the walking surface. I'm just looking at a question I want to briefly address. Charles Putterman asks about the slide that has the ramp with the yellow on the sides. And I'm assuming that's the slide that shows the large area of yellow ramp. And let me see if I can put that back up on the screen without too much disruption. But at the entrance to a grocery store, the loading area is often ramped and painted yellow. Now, the yellow paint serves a function. The question is, and if you'll excuse me for just a second, I'm going to put that slide up so that we're talking about the same thing. Yeah. Charles, I believe that's the slide that you're referring to. You can correct me if I'm wrong. So the question is the painting required by code? And the purpose of that painting is to alert pedestrians that there are elevation changes and slopes. So the painting, the coating that we see there, has the function of enhancing the safety by providing a warning of a slope and a change in elevation. It can also compromise safety if there is not some grit put into the coating. Now I'm getting some feedback from Charles. Again, the ramp I was referring to in my question was the small ramp rising from the parking level to the sidewalk level in a shopping center. Yeah. So with that one, again, the yellow paint does provide the same function. I'm just going to go to that slide while I address it. In this area, there's yellow paint at the edge of the curb. And again, the purpose of that yellow paint is twofold. One, it's to warn against parking so that the ramp is not blocked by somebody who parks at the curb. And it's also to warn pedestrians of a change in elevation. Yeah. Hey, Charles, was that the slide that you were referring to? No, I have feedback that the slide is the one with the paint on the sides of the ramp. So I think that was an asphalt ramp. And I'm going to pull that slide up. This is the hunt for a slide. Yeah, so I think that covers all the ramps with yellow paint that we've got. That's the one. Okay, thank you, Charles. And again, similar reasons for this. Obviously, that one's not there to prevent people from parking. That's the yellow flares that we see on the side of the ramp can be a tripping or stumbling hazard, and so they're painted yellow to warn pedestrians who are stepping down from the curb or stepping up to the curb that there's a change in elevation and a slope. Thank you for that question, Charles. We'll move on to the slide that we left off of and continue with a little bit of a general discussion. For any hazard in the built environment, notice can be given. We were just talking about notice from Charles' question, such as painting the edge of a hazard yellow. However, notice is not a substitute for eliminating the hazardous condition if it is possible to eliminate it. Similarly, the severity of a hazard is influenced by the level of supervision associated with that particular area of the built environment. For instance, in an industrial walkway restricted only to use by trained personnel, like this industrial catwalk, would have a different burden of safety than, say, a stair in a private residence or a stair along a handicap-accessible walking route. Obviously, that's a higher burden because it's both used by the public and by persons who may have a limited physical ability. A long handicap-accessible ramp or public sidewalk, different burdens apply as well. And we talked about how a curb is something that it should not be a surprise to most people, as we expect to see one or at the edge of a sidewalk between pedestrian traffic and vehicular traffic. I'm looking at a question from Bob asking, does weight of pedestrian on wet, mildewy surface affect slipperiness of the surface? That is, does a heavier person have a greater likelihood to slip than a lighter person? Now, according to the laws of physics, Bob, the coefficient of friction does not increase as a function of weight. It simply is the ratio of the slip resistance to the horizontal load, the horizontal force required to cause slip to the vertical weight. So if somebody were, say, 200 pounds with a coefficient of friction of 0.5, it would take a 100-pound horizontal force. So the same surface would act to require a 400-pound person to require a 200-pound horizontal force. Same ratio, same coefficient of friction. However, there would be a temptation to think that because a heavier person requires a greater horizontal force to slip, he's actually safer. Intuition tells us that it might be more likely for a heavier person to slip. And the reason for that would be that a greater vertical load that is out of alignment with the vertical causes a greater horizontal load. And so somebody who is heavier might be less stable and might rely on horizontal traction or the slip resistance of the surface in taking each step, might rely more because of a physical awkwardness or some other reason that may not have anything to do with pure weight. So I think the effects that you are speaking of, Bob, can be best addressed with biomechanics rather than a discussion about the slip resistance of the surface. But suffice it to say that the slip resistance does not change, but the possibility of slipping might. So, to summarize, many types of walking surfaces exist to accommodate many types of foot traffic, but all are governed by commonly accepted standards. So an architect or engineer with similar design experience is qualified to evaluate the unique aspects of inherent safety of any particular walking surface. So now I'd like to take a few moments to answer any further questions that you might have. If you have a question, however basic or technical, please take a moment to type your question onto the board, and I'll do my best to address your question as we have time and as I'm able.
Sure. Thank you so much, Bob. We do have a question here from Michael who asked, did you say a half an inch or 1 and 1/2 inches is the standard gap in cement?
Well, in a walking surface, most regulations limit the opening size to 1/2 inch. Not the 1 inch, but to 1/2 inch.
Okay, great. So that would be 1/2 inch in walking surfaces. Thank you.
That's right. Yes. Yep.
Okay, we're now going to open it up to questions. So if you have any questions for Bob, you can use the chat or Q&A feature found on the right-hand side of the screen to submit them. We do have some questions that have come in, and we'll start with those. Bob, what's meant by the amplitude of a surface?
The amplitude of a surface just refers to how much distance there is vertically from the highest point to the lowest point, similar to the amplitude in a sine wave or an oscillation in physics. So a surface that has very large grit particles put into, say, a coating would have a larger amplitude, and therefore more opportunities for mechanical interlock with the foot.
Okay, great. We have another question here that asks, most stores have a raised strip at the threshold. Isn't that a tripping hazard?
Yes, a threshold can present a tripping hazard, and so there are regulations to limit the height and the slope and the color of the threshold. Now, the regulations that limit the color are more rare, but the height and the slope is pretty clearly regulated. Typically, 1/4 inch is the maximum height, and the slope should be at least a 45-degree angle for that 1/4 inch. It certainly helps if the threshold is a lighter color against the darker floor, and it also helps that most people expect to step over something when they go through a door. But that's not something that can be relied on. It's not an expectation that can be relied on to the exclusion of good design.
Okay, we have a question here from Bob, and I'm not sure if we covered this. I was trying to sift through the audio issues that we were having earlier in the presentation. So I just want to touch on it, and if you already covered it, we can move forward. Bob asked, what is the standard for maintenance and cleaning of mildew on a patio tiles at a rental house at a resort?
Yeah, there are very general maintenance standards that just prevent a maintenance neglect from causing a hazardous condition, and I think this might fall into that category because it could serve as a contaminant. The mildew could serve as a contaminant to increase the slipperiness of the patio. And since the house is not being occupied by the owner, there might be a greater burden to provide the guest at the rental with accommodation by preventing a slipping hazard like that.
Okay, great. We have 2 questions here. One from Michael, who asks, if you are in a bathroom that is very small where there was an alleged slip and fall, does it make sense to do a coefficient of friction test?
In a bathroom that's very small, coefficient of friction test, I can't think of any reason the size of the bathroom would affect that. The coefficient of friction wouldn't be affected by the size of the bathroom. And maybe you can help me out with what angle we want to look at there. But yes, the coefficient of friction test could provide useful information. It won't tell everything. Obviously, if there are some other factors that might have caused the fall, such as a water leak or something related to the size of the bathroom, difficulty turning around without compromising stability might also be looked at.
Okay, great. We have a question here now from Steve, who asks, he's working on a case where a drywaller was working above an open stairwell. His scaffold collapsed and he fell to the basement. There's an argument being made a cover was required rather than a guardrail. Is the industry standard for a cover or a guardrail in this instance?
Yeah, that's walking surface, or in this case a working surface, is governed by OSHA. And I can't cite the specific section as I sit here, but OSHA does have a section on fall protection for working surfaces on construction sites. And there are several options that OSHA gives for fall protection. So that guardrail could be one, unless, of course, it creates an inherent hazard by being in the way of the person who's doing his job. That inherent hazard could be that it could cause the person to lose their balance, or the person might get fed up with it and take it down so that they can get their work done. So, in some cases, a cover is preferable to a guard.
Okay, great. We have a question here from Stuart who asked, could you say a few words on gradings on sidewalks? Subway gradings in sidewalks and or steel curb attachments?
Yes, the gradings, we talked about briefly, the size or the gap between the bars in a grading must be limited, usually to about half an inch, to prevent small heels from going in. Also, all the elements of a grading on a sidewalk should be flush, should be level. So even if the bars are close together, if one bar is sticking up, that could be a tripping hazard depending on which direction traffic goes. And as we know, traffic goes in all directions on a sidewalk. So those two factors should be taken into account, the flushness and the width of the gap between the grading bars.
Okay, we have a question here from Damien who asked, can you go back a couple of slides and tell us if that parking block is a hazard? Should there be a guardrail in front of it? It seems like it would be a hazard to have a parking barrier right outside the door. Go back 2 slides. So I guess this is the slide he is talking about.
Yes, Damien, I think you're referring to the restaurant that will remain nameless that has a wheel stop, a parking wheel stop in front of the door. There are several things that can be done to mitigate. The first thing is maybe not to have a parking space right in front of the door. But what we see is that there's a reason to get parking spaces as close to the door as possible. The clue is the handicap signs that we see there. So that has to be balanced. The need to get a handicapped parking space close to the door so it's easier for a disabled person to get in without causing there to be more disabled people by having a tripping hazard right outside the door. So that's one thing that must be balanced. There is a loading zone, as the Americans with Disabilities Act calls them, between two handicapped parking spaces. That's the striped area. That's there so that people can get in and out of a car if they're disabled. However, it also provides a walkway, and something of that sort can be helpful in directing people to walk between the blocks rather than around the blocks. But as you see, this particular loading zone is not aligned with the door, and so its usefulness might have some limitations because of that. A handrail or a guardrail in front of that hazard certainly is a way to keep people from walking into it because the guardrail is higher. But it may not be the ideal situation in front of the entrance to your building. My suggestion as a designer would be to open things up a little bit in front of the entrance to make the entrance more accessible without barriers.
Thank you. We now have a question from Baxter who asks, does the 1/2 inch gap standard in concrete also apply to the floor of a retail big box store?
Yeah, Baxter, in general, the 1/2 inch applies to all walking surfaces. Obviously, inside a building, one would hope to eliminate any voids at all because it's a more controlled environment. There wouldn't be a need for a steam grate, for instance, or a stormwater inlet inside the building. And so there would be the hope to eliminate all openings in the floor. But the 1/2 inch standard would be a reasonable measure if it's unavoidable.
Okay, we now have a question here from Lee who asks, what are the standards for setting up a display in a supermarket involving liquid dish detergent where the boxes had to be slit open with razors, causing liquid to seep out on the floor? It wasn't cleaned up and someone slipped.
Yeah, again, a designer can only go so far in anticipating contaminants on the floor. So let's take it from design, then construction, and then maintenance. For design and construction both, it's possible to put lighter colored floors and direct lighting to highlight or reflect off of any spills so that people who are walking in the area get some fair warning. However, this problem falls mostly in the category of maintenance. It is incumbent upon the owner of a property to provide safe maintenance practices so that if there is a hazard on the floor, maybe one that was caused by an employee of the owner, and is known to the owner or to the owner's employee, then that should be taken care of right away. And there are some practices that, again, a designer or contractor has no control over, but a store owner does, such as putting up barriers or you've seen the cloth tripods, cloth-covered tripods that warn of a slippery area that can be stored in a very small pocket at the end of each aisle. A designer can provide a place at the end of each aisle for these warning tripods to be put so that if there is a spill in the aisle, they can be very quickly taken out. And, of course, personnel have to be trained to use them and to prevent customers from walking up that aisle until the spill can be cleaned and dried.
Okay, great. It looks like we have two more questions for you, Bob. This one comes from Brian, who has a question regarding the Americans with Disabilities Act involving ramps. He's working on a case where a patient who's wheelchair bound due to MS was ingressing to a doctor's office up a ramp, and one of the wheels fell off the side, and he fell. Are there railing requirements under the Act concerning ramps? And are the codes/requirements per state or all consistent per the federal government?
Well, the first part of the question about railings and ramps we talked about during our time of bad audio, I think. And so let me just get to that slide so that we can get the benefit of that again. And I apologize for the audio problem. But here are two possible ways of handling or preventing the problem that Brian described. One would be to extend the surface beyond the handrail so that a wheel or a pedestrian's foot can't go over the edge of the ramp. Another is to have a barrier. And that barrier could be the bar that is seen under figure B on the right-hand side, or it could be a concrete curb, a continuous concrete curb. And of course, a railing is necessary to prevent a fall over the edge of the ramp. Railings are not required on the sides of ramps that are 6 inches or less, and that is primarily to prevent the need for railings at curb cuts so that they don't become an obstruction to pedestrians or a tripping hazard themselves. The second part of the question, whether or not this is uniform across the country, is yes, effectively it is uniform across the country, as the Americans with Disabilities Act is a federal statute. Now, the federal statute does not function exactly the same as a building code. In other words, some municipalities or some states, and I don't know of any offhand, might issue a building permit. Whether or not the Americans with Disabilities Act design guidelines have been followed. However, that would not stop the owner from being sued under the ADA provisions if those guidelines were not followed. So the ADA does serve as, excuse the expression, a safety net for people who need to have protections and barrier-free walking surfaces.
Okay, great. We now have a question from Jennifer, who asked that they're handling two matters. One, where an individual tripped in a slightly uneven paved surface with deterioration in pavement. Can you go back to the void slide in the beginning and just cover that just briefly? I think that was during the scrambled audio as well.
Yes, and I'm sorry, I was looking for a slide that was illustrative of that, but I missed the question.
Oh, yeah, sure. She is working on a matter where an individual tripped in a slightly uneven paved surface with deterioration in the pavement. Can you go back to the void slide in the beginning and just discuss that topic briefly?
Yes, the issue that deteriorated concrete presents as a hazard falls into two categories. One, a void that could cause a destabilization if the void is large enough as the pedestrian steps into the void. The other is that deteriorated concrete can present a vertical edge, as seen here. The vertical edge can then serve as a tripping surface. So this again falls into the category of a maintenance problem rather than a design or a construction problem. However, there are design measures and construction measures that can make it less likely for these types of voids or for pavement to deteriorate.
Okay, great. Thank you. We now have a question from Stuart. This is a follow-up to the liquid detergent falling on the grocery floor.
Okay.
He asks, what if the display is put in the wrong place in the supermarket?
I need a little more background on that.
I'll go back to his original question. I'm sorry. His original question was,
yeah, I think the scenario was painted of an employee opening crates of detergent and the box cutter cutting open the detergent bottles in a spill.
Yes.
And I think it was put on, this activity happened at a display.
Yeah, I think they were setting up a display, you know, like a free sample or this is how it works sort of thing. And it says if the display is sticking into the aisle. So I guess the employees were putting the display up incorrectly.
Yeah, again,
put some clarity to that question. We could do our best to answer it. If you're still on the line.
Yes, I'm understanding the question. If the display is put in a place where it obstructs pedestrian flow of traffic or because of the spill associated with it, makes a slipping hazard. Again, that would fall into maintenance problem or an operational problem that the store owner and management should institute and enforce policies that provide clear and unobstructed walking pathways for customers. It may also fall into the design sequence or to the design responsibility if the type of operation requires more display area than the building can afford in its original design layout. So sometimes if people are crowding the walkways with merchandise, it's because they didn't plan during the design phase to have enough place to display their wares, or it could just be that good design did take place, but the market changed and there's a need for more display space.
Right, and we do have a clarification there by Stuart who says, here's, I guess, the crux of the question, is there a standard of care or is there a standard for width of aisles in supermarkets prohibiting displays?
Yes, normally the width of an aisle would be dictated by the need for people to get out of the store in an emergency. Typically, a minimum width is 44 inches, and that width increases as the number of occupants that could potentially be in the building increases.
Okay, and this will have to be our final question because we're going to wrap things up here pretty shortly. Gerald asks, some stores sell water by the jug and allow customers to bring in their own jugs. When the jugs are filled in the store reports that it is aware that customers spill the water on the way to their cars. He has a client that fell in such a puddle. What should the store do to correct the situation? Is there a design issue there, or is that are there other issues there?
Well, we can start with the design consideration. If the designer of the store is aware that the general public will be handling open containers of water, it would be best to provide the watering station, the jug filling station, in a place where the general public would cross as few critical walking surfaces as possible. Obviously, it's not possible to eliminate all intersections between people carrying water and walking surfaces because people carrying the water are on a walking surface. So that leaves some burden on the owner of the property to institute regulations to deal with the potential. So it may mean having a job description or some other operational convention where a person or persons are responsible for mitigating those types of hazards, or at least notifying customers of them until they're mitigated.
Okay, great. I don't see any other questions in the queue, so I'm going to wrap things up here. First of all, I'd like to thank everybody. I'd like to thank Bob, and I'd like to thank all the attendees for being patient while we rectified the audio issue. It was something that neither Bob nor I were in control of. It was the teleconference service that we were working through, and it did get rectified, and I'm glad. For the questions in the second half of the presentation, the audio was, for the most part, clear. And I do thank you for staying on with us and being patient. That meant a lot to me. If you would like to speak to Bob about a case or a project, please contact us here at TASA. You can either call us, our number is 800-523-2319, or you can email me. My email address is mhyde@tasanet.com, and I'll send that around to everybody in the chat. You'll get an email from me probably around 3:30, thanking you for attending. My contact information will be listed there as well. We will be sending out a link to the archived recording of this webinar tomorrow morning. In the email that contains the link, you'll also have a copy of the PowerPoint presentation. This and all of the archived recordings of TASA webinars are in the TASA Knowledge Center. If you go to the TASA homepage, just click on the Knowledge Center tab at the top, and you'll get to the webinar section. And again, if you have any follow-up questions or comments, we welcome all comments. They help us make better programs, or I should say they help us put together better programs. So please feel free to either call me or email me with your comments, and we'll make sure that we take them under consideration. On behalf of the entire TASA group, I'd like to thank Bob for putting in quite an effort. I thought his presentation was great, and his patience was very good as well. And for all of you who joined us, I thank you, and I apologize for any inconvenience during the first half of the program. Thank you again, and we look forward to seeing you at future events.